Everyone, our group name is Reverse-Brook. So we're gonna introduce you the Brook rearrangement today. So you can see our group members here. So the Brook rearrangement is named after the Canadian chemist. His name is Andrew Reverse-Brook, and this is his photo. So let's have a break look at the basic reaction. The Brook rearrangement is under the environmental base. So we got the base here. And as you can see from the oxygen, we have the hydrogen atom, and from there's a silicon atom bound to this carbon. And then we have a look at our products. We only on this oxygen, there's a silicon replace the hydrogen, and there's a hydrogen replace the silicon, right? So the Brook rearrangement is change the in brief is change the position of this hydrogen and this silicon. Change their position, right? So what's the bracket here? And there's an N beside it. The N shows the number of the atom, the carbon atom. So you can have 0 carbon atom or 1 or 2. That depends on what's your starting material is, right? So let's move on and have a look at the reaction mechanism. So you will after learning this, you will get to know how this reaction happen. So under the basic environment, there is a lone pair on the base, right? Then this lone pair will attack this hydrogen, and then this bond will give our oxygen the positive charge, right? So there is 3 lone pairs in the hydrogen, and the hydrogen got a positive charge, and it will attack this lone pair will attack this silicon atom, and then we have a transition state. It's a 3 membrane ring, right? And this bond is gonna to produce, and this bond is going to break, right? So this bond break, then we got a positive charge, a negative charge on the carbon, and this positive charge will attack. So this arrow that will attack this hydrogen, and hydrogen then bound to the carbon, right? And then that is our product. Then we have a loss of a positive charged, negative charged base, right? So the Sicily substitution, I think it's this one, right? It can be such as methyl or phenol. So those all can be the Sicily substitution. And for our base, you can use amine or lithium or alkali metal alloy, such as such as this one. It's called sodium potassium, and the sodium hydroxide is this one. So you can use this base in the Brook rearrangement. And after we learned the normal base Brook rearrangement, there is a special one, which reactant is with carbonyl. So this is one carbonyl, right? So the normal one is with hydroxyl, I think, hydroxide, and the special one is with carbonyl. So the same thing is that under the base environment. So this lithium atom is replace the hydrogen, right? And this lone pair here will lone pair on the oxygen will attack the lithium atom, and the carbon here, the double bonds will break and give electrons to oxygen. And then we got this one. So lithium bonds to oxygen, and still under the base environment, this lone pair on the base will attack to the lithium, and this bond will break and give oxygen lone pair, actual lone pair, and this so the oxygen has a positive charge, negative charge, and this lone pair will attack to the silicon atom and has a transition state, a 3-membrane ring, and this bond gonna break. So the carbon will has a positive charge of negative charge, and the negative charge will attack to the same base, right? The same base will attack to the lithium atom or base, and this bond will break. And so we got our products. So this time, lithium atom attached to the carbon, the carbon, and on the oxygen there is cis. So I think this is a very important example for Brook rearrangement. As you can see here is the total reactions, and right here is the starting material, and right here is the product. They looks like the same, but actually they are not the same, right? Because as you can see here is there is a plus symbol, and right here is a minus symbol, which shows that they are different. And from the blue block, this one is represent the minus symbol one, and this one is has the this one is the plus symbol, and this one is the minus symbol. So they are overlapping through the mirror. We don't need to understand the whole reaction, but we need to focus on this because it went through the Brook rearrangement. And under the basic environment, right, this is what we talked before. The sodium potassium is a base, and right here, as you can see, there's a hydrogen beside the oxygen, and there is a silicon atom with three different R groups. And under through the base environment, we got the silicon atom replace the position of hydrogen and bond to the oxygen, while the hydrogen get to the replace the position of silicon atoms, right? So next we're gonna teach you the Reverse-Brook rearrangement reaction, but we won't give you same amount of information like Brook rearrangement reaction, because it's just actual information, right? So from this reaction, we have a silicon atom bond to the double bonds, and another silicon atom with a superscript M right here. And with under this, go through these regions, we got I think there's a double bond here, and we got so at least silicon is right here, and it's beside the double bond, right? And this silicon with superscript M get touched to the carbon with this silicon atom. So in us understanding this Reverse-Brook rearrangement, just give the silicon atom beside the oxygen, move it to this carbon with another silicon atom. So this product's gonna be divided into two aspects. And so just have a brief look, and we won't explain too much. So that's the end of our teaching, and those are our reference lists. And you can have a brief look. And Thank you so much for listening. Don't forget to subscribe our channel and give us a thumbs up. Thank you.